Hello, 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 everybody, and welcome back. We're looking at question, or should I say problem number 4 on part 2 of our 2017-2018 Alberta High School Math Contest. So what have we got for problem number 4? A collection of items weighing 3, 4, or 5 kilograms has a total weight of 120 kilograms. Okay. Prove that there is a sub-collection of the items weighing exactly 60 kilograms. Okay, so we don't know how much how many things weighing 3, or how many things weighing 4, how many things weighing 5 we have, but we're told they add up to 120. So what we could do is, and remember this is a written question, so you probably want to explain. You could say, all right, let x equal the number of 3 kilogram items, y the number of 4 kilogram, and z the number of 5 kilogram items. Okay. Then we get a nice little equation. 3 times x, so the number of them times the weight, 4 times y, 5 times z is 120. What we'd like to do is show that there is sort of a, we can say we need p less than or equal to x, q less than or equal to y, and r less than or equal to z, so that 3p plus 4q plus 5r is equal to 60. That's what we want. We want to find this. And they have to be less than or equal to the x, y, and z. Because if I only have 10 things that weigh 3 kilograms, I can't just say, oh, 20, 0, and 0 will work. Well, you don't have 20 of the things. That's what they mean by sub-collection. Okay, so there are different x's, y's, and z's that will work. What can we do from here? Well, actually, building off of that idea, if I did have 20 x's, then I could just take p as 20 and we'd be done. It doesn't matter what x and or what y and z are. We can make that observation. I would say it is clear if x is more than 20, y is more than, so for 4 you would need 15 of them. And with 5 you need 12 things. We could do this. Just take p is 20, or q is 15, or r is 12. So going forward, we can assume that x is at most 19. You have at most 19 things that weigh 3 kilograms. There are at most 14 things that weigh 4, and there are most 11. And 11 kind of, that seems very restrictive for the z. The number of things with that weigh 5 kilograms. All right, so that's fine. What else can we do? So that's sort of obvious, and that might actually not be necessary. And this was nice, but this might actually not be necessary. But okay, whatever. We can at least demonstrate, yeah, we've thought a little bit about this. Maybe this is worth a mark. I'm not exactly sure what the marking scheme would have been for this question. But, okay, that certainly limits things, smaller values of x, y, and z. But it's still kind of not particularly helpful, right? Because I don't want to go case by case. Oh, if x is 1 and y is 1, then z has to be, and then you can do one of these, none of these, and 10 of these. You know, you don't want to do that. And that's a bad approach to the question. Solving individual cases isn't going to help. And there are too many combinations in here that could make 120. At least I think. So you wouldn't be done in the 3-hour time limit for the whole paper, let alone the what should it be? 36 minutes that you should be given to each question. So what can we do? Now, we've got 120. Why 60? 60 is a half of 120. So we can make the observation, if x is, let's say, 2a, and y is, say, 2b. So if all of these are even, getting rid of the 2, dividing both sides by 2, you would get what you want. So if they're all even, you automatically get 60. So that's another sort of simple observation. Maybe there's a way to show that you always have to have an even number of these things. Let's see what we can do. Suppose I wanted x to be 1. That's a pretty nice odd number. And maybe y is... Well, now we have to be a little careful. So we get, subtracting 3, you get 117. That's a multiple of 9, so if I divide through by 9, you get 1, 3. So if I let each of the other ones be 13, so I guess they can be odd. Maybe they can only be odd or even. Is there a way to do this? Well, if I take away 4 of these, and I add on 5 of these, that should still do it. 3 plus 72 is 75, plus 45. Yeah, that would work. So that's kind of interesting. Okay, so you can get odds and evens. Obviously, if they're all even, that's fine. If they're not all even, what can we do? So maybe we should start looking at this when it comes with parity. So, what to do, what to do, what to do. Well, when it comes to parity, all right, so x can be odd and we can still get other things. And we showed that y could be odd and z could be odd. We also found y could be even. Add 5 to the 13, we got 100, or we got 18. But y, z would have to go down or up by 4 each time. So I think we rearrange this. This is 2 times something. So this side has to be even. So I would, if I were writing this up, I would say notice this. If x is odd, 3x is odd. This over here is even. So if you got an odd plus something and your sum is even, then you'll have 5z is odd. Therefore, z is odd. So if x is odd, z is odd. And similarly, if z is odd, x is odd. The exact same reasoning, just sort of in reverse. If z is odd, 5z is odd. Odd plus an odd makes an even. So 3x is odd, and 3 is odd, so x is odd. The only way to get an odd product is if each of your factors is odd. Because even as soon as you got one factor, 2 in there, it spoils the whole thing. Okay, so what we can conclude is x and z have the same parity. And parity is just a fancy word for oddness and evenness. If they have this, if 2 numbers have the same parity, then when one is odd, the other one's odd. When one is even, the other is even. If they have different parities, then when one is odd, the other one's even. When one is even, the other one's odd. But that's kind of interesting. X and Z have the same parity. So we looked at if they're even. Now that this is sort of only going to be 4 cases. And maybe we can rule out some of these. So if everything's even, if x and z are even but y is odd, now I don't have confirmation that all of these can happen. We have at least seen some of them happen. For example, I did show that they could all be odd. So I know for a fact that one and that one can happen. Well, actually, I never showed that the even ones could happen, but just take 40, 0, and 0, and you're all set. And this case is already dealt with. Just divide everything by 2 and you're good to go. Kind of interesting. I know this one can happen as well. What about this one? Can we get x and z to be even but y to be odd? Just out of curiosity. So let's borrow a little scrap piece of paper. If I let x be, well, let's not go with 40. Let's say 38. So 3 times 38, so that should be, that's a difference of 6. That's not going to work. X and Z. If I let x and z be equal, then we get 3 times something plus 5 times something. That's 8 times something. And that's a factor of 4. So yeah, that should work. So maybe let x and z both be 10. Then 3x plus 5z is 80. And so you'll have 40 divided by 4, that's 10. No, that's not going to work. Now you'd have to have an even number for y there. Maybe let x be 36. And 3 times 36 is 108. And then to make 120, you need 12, so that would be 3 and 0. So 36, 3, and 0. Yeah, okay, so all of these 4 possibilities can be done. Now, so these are possible, but you'll notice you can't have x is odd, z is even, and y is even, or something like that. So we know how to handle this one. We already observed that. What if I have the other ones? Right? For example, we had 1, we had 18, and we had 9 here. But of course, 18 is more than 15, so you can just automatically do this. What's the bare minimum x I need to ensure that y and z are smaller than these limits? So I know x is at most 19, y is at most 11. No, not 11. Z is at most 11. Y is at most 14. And we know 120 minus 3x minus 4y is equal to 5z, so divide by 5 there. So we should be able to get a handle on what z is. Right, so hold on. Y is at most 19, so x is at most 19, so 3x is at most 57. Y is at most 14, so 4y is at most 56. Z is at most 11, so 5z is at most 55. And so combining these, we also know 120 minus 3x minus 4y. The biggest you could be subtracting is 57 and 56. So whatever this is, this has to be more than if you just subtracted off 57 and 56. So that's 100, so that's 20 gone, or so 20 left, minus 7 and 6, so that would be 20 minus 13, so that's 7. So 5z is bigger than or equal to 7, so z has to be bigger than or equal to 7 over 5, which is just a little bit more than 1, so z is at least 2. You have to have at least 2 things that weigh 5, assuming you don't get the obvious solutions. Okay? We should be able to do this for the other ones. 120 minus 3x minus 5z is the smallest it can be is if you took off the 57 and the 55. And so that'd be 120 minus 100, so that'd be just 20 minus 5 minus 7. So that should be 8. So 4y has to be at most 8, so y also has to be at least 2. And 4y, 5z, 56 minus 55. So now it's 20 minus 11. 6 and 5 is 11, so that'd be 9. So 3x is at most 9. X has to be at least 3. Okay. So x is at least 3, y is at least 2, and z is at least 2. Interesting. And of course, this is assuming that x is at most 19, y is at most 14, and z is at most 11. Okay, so now going back to these cases based on parity. So if x equals 2a, y equals 2b, I'm just going to summarize what we already know. Let p be a, let y be b, and let z be, or let q be b, and let r be c, which is a bank. Now, what if you had 2a, 2b plus 1, and 2c? So a would have to be at least 1. C would have to be at least... Actually, no. X has to be at least 3. So in this case, x has to be at least 4 because x is even. So a has to be at least 2. Z in this case has to be at least 2, so c has to be at least 1. But y is at least 2, but it's odd. So y is at least 3, b is at least 1. And I don't know where to go from this. If they were all even, I could divide again, but I don't. I've got sort of this extra factor of 4. So we know we've got this. I've got 6a plus 8b plus 4, and then 10c, 120. If you subtract by 4 on both sides, we got 116 is 6a plus 8b plus 10c. Divide by 2, 3a plus 4b plus 5c is going to be, let's see, divide by 2, so 58. So that's if I just took A of them, B of them, and C of them, but we're missing 2. We're missing 2 kilograms. Is there a way to make 2 kilograms here? If I got rid of an A, if I bumped A down by 1 and C up by 1, we should be fine. So let P be A minus 1. Let's let Q be B, and let's let R be C plus 1. Now C is at least 1, so C plus 1 is at least 2. But Z was at least 2, and so we should be good to go. So this is okay. And then we see 3A minus 1 plus 4B plus 5C plus 1 should be 3A minus 3 plus 4B plus 5C plus 5, and that makes my remaining. So the minus 3 and the 5 give me the remaining 2, and I get 60. So great, this case is done, this case is done. So obviously C is half of Z, but adding 1 should still be less than Z. We're good to go there. Okay, what if, so that was evens and an odd. Let's do These two are odd, and we'll say y is even. So if that's the case, x has to be at least 3. So, well, it might be that a is 1, and you get the smallest you possibly can. Y needed to be at least 2, so b is at least 1. That's fine. Z is at least 2, but therefore, because it's odd, Z is at least 3, so C is at least 1. So we at least have one of each A, B, and C. Now, 3 2A plus 1, 4 2B, 5 2C plus 1 needs to be 120. So we'll get 6A plus 3, 8B, 10C plus 5. So subtract 8 on both sides. Get 112 is 6A plus 8B plus 10C. Divide by 2, we should get close. But again, we'll be off ever so slightly. We'll have 56, so we'll need an extra 4. So just use B plus 1. So B plus 1 should still be less than Y. Right? Here's why. I don't think I made it clear over here because I was talking, not really writing. So here's what it is. B is at least 1. So Y, which is 2B, is at least 2, but that's going to be B plus B. And B is at least 1, so this is greater than B plus 1. Okay, so that's why we can do the following. Just let P be A, let's R be C, and we can let Q be B plus 1 because we know there are enough of those. Right? Because Y is at least 2, so B is at least 1, so you're going to have at least an extra one kicking around. So great, we're working this out. We've got one more to go. And so that's if everything is odd. But we seem to be falling into a nice rhythm. We work out what the sum currently is. We divide by 2. And then we just sort of make up the difference by playing around with this a little bit. So we know this has to add up to 120. So that's going to be 6A plus 3, 8B plus 4, 10C plus 5. So 6A, 8B, 10C, our sort of go-to is subtract off 12, so 108, divide by 2, 3A plus 4B plus 5C is 54, so we need to make up 6. X is at least 3, so A is at least 1. Y is at least 2, but since it's odd, that means Y is at least 3, so B is at least 1. And Z is at least 2, but again, it's odd, so really Z needs to be at least 3, so C is at least 1. Okay. Now, take your A, B, and C, and now I need to find a way to add on 6. Now, before we added on 2, how can we add on 6? Well, if I had a couple extra A's, that could work. But can I always add on A plus 2? Well, if X was 3, A would be 1, and so you'd have 3 of those. So that would work. If X were 5, A would be at least 2, and you could add on 2 of those. So yeah, I think we just need to add on a couple extra here. So X is 2A. Which is at least A plus A. Oh. So I guess here's what we could say. If x actually is equal to 3, a plus 2, a is 1, a plus 2 is 3, which is less than or equal to x, which is good. If x is bigger than or equal to 5, a is at least 2, and so x is 2a, which is a plus a, which is greater than or equal to a plus 2. So once again, a plus 2. Either way, a plus 2 is less than or equal to x. So we're just going to take p is equal to a plus 2. A plus 2 is less than or equal to x, so that works out because we were dealing only with odd numbers. We'll let q be b, and we'll let r be c. And there we go. So those are the 4 cases. We narrowed it down to 4 rather than 8, thanks to working with parity. Okay. And then limiting ourselves to the not obvious cases, we then sort of worked out some stuff with x, y's, and z's, just with bare minimums. But knowing that we had certain smallest numbers allowed us to sort of fiddle around and find extra weights when we needed them. And we just worked through the 4 cases. It took a little while, but there wasn't really any point where I felt particularly stuck. It was more just each parity case, each of the 4 parity cases presented a slightly new challenge. And these probably aren't the only ways to go about doing it. I mean, maybe you can add an extra b, add an extra c, and subtract an a. That would make 6 as well, wouldn't it? I see no reason why you couldn't do that. So, I mean, there's probably a couple different ways to answer it. It's just a question of how do you show off that your particular p, q, and r will in fact work. Okay, so there we go. That's question number 4, or problem number 4, all squared away with. Up next, we're going to take a look at problem number 5, the last question on our part 2 paper. So if you haven't given it a try, please feel free to do so. And I'll see you for problem number 5 in the following video. Take care and have a wonderful day.